The original idea of design patterns came from, guess what? Architecture. I mean, civil architecture, not software architecture. In the 70s, this Austrian architect called Christopher Alexander noticed that there are things in our way of building that stay the same pretty much everywhere and throughout history. For example, take the idea of the promenade, the walking street. Ancient Roman cities had this large street where people could take a walk and mingle with other people, and so do most modern cities today all over the world. Sure, no two of these promenades look exactly the same, but the basic idea stays the same. Technology changed an awful lot, culture, even the concept of a city changed, but the promenade seems to be a constant. So Alexander said, this is a common or usable solution to a common problem. Let's call it a pattern. And he could see many such patterns, all the way from city planning down to individual rooms. For example, he said, rooms that feel cozy and comfortable tend to have windows on two sides. This is a common pattern, let's give it a name and study how it works. So he got a few collaborators together and they wrote a book that collected hundreds of such patterns. So that's what a pattern is. It's a solution to a design problem that works well in general. So you see it applied over and over again, with variations. It's not something you invent from scratch, more like something you discover while looking at existing solutions. And then you can give it a name and discuss when it works, when it doesn't, concrete examples, and so on. This was a brilliant idea, but for some reason it never really spread much amongst architects. And then, after a few years, something unexpected happened. What happened was this developer, Ward Cunningham, one of my personal heroes, by the way, he invented so many great things. So, in the 80s, Ward and a few other people like Kent Beck read Alexander's books on patterns and they thought, hey, this idea would be a perfect fit for software. Like object-oriented design, we all see people rediscovering the same solutions over and over again. Why don't we write down those solutions as patterns? So they started a movement. Ward even created a site to discuss patterns. It was this weird website where anybody could edit any page, which was an idea that couldn't possibly work. Yeah, and that's how Ward Cunningham invented the wiki, but that's another story. Next thing to happen in patterns, this book. It was written by four developers who became collectively known as the Gang of Four. And it was kinda like the equivalent to Alexander's catalog of patterns, only for software. This was 95, so the book's examples were written in Smalltalk and C++. But these ideas really had an impact on the Java community, which was brand new, and later on the C# community. After that book, people wrote many more books on patterns, including a few really good ones. However, even today, the original book is still the bestseller, for one simple reason. It almost nailed the basic catalog of patterns for object-oriented programming. Sure, if the book came out today, then a few of the original patterns would probably be replaced, but still, even today, when people talk about design patterns, they mostly talk about the 23 patterns in the Gang of Four book. In this short training here, we're only going to talk about structural patterns, the ones that focus on the relationships between classes and objects, and we will also skip a few of those, because they're either really simple or they just didn't prove as useful as the others. So we're going to focus on just these few patterns. One last note before we go back to concrete examples. It's easy to misunderstand patterns and think that they are prescriptive, that you can design a system by picking the right patterns and following them like a blueprint. That would be a mistake. A pattern is not a blueprint. It's more like a cooking recipe. My apple pie is probably different from your apple pie, and likewise, each pattern has many variations. In the previous clip, I showed you one way to build an adapter, but you can find many more, including a few that have a very different structure. Now, the engineer in me is almost tempted to ask, well, if patterns are not instructions, then how are they useful? Well, there are two reasons why patterns are useful, and they both have to do with communication. First, Patterns are a great way to label design ideas. If we are programming together, then you don't have to say, look, Paolo, maybe we can wrap these objects into other objects that expose a different interface so that we can pass them to that client. Instead, you can just say, hey, we could use an adapter here, and I will know what you mean straight away. And the second reason why patterns are useful is that they are teaching tools. If you write object-oriented code for a few years, then you might well rediscover the concept of an adapter on your own. But you don't need to do that. Instead, I can come to you and teach you, this is a common problem and here is a solution for that. It's called an adapter, and so on. And that is the power of design patterns. They are both a discussion tool and a teaching tool.